The best way to make use of this video is to pause it as soon as the question is put up. Try the question on your own and only then continue. Mind you, I'm not going to pause even momentarily once the question is put up, and I'm just going to continue explaining it. If you like what you see, the links to our courses is in the description below. An interesting question. X and Y are positive real numbers and we're given an expression. Now you should have realized that X and Y are three terms. So it should be factorizable. So let me just copy it as it is. You should not be doing this. So plus 10x plus 15y is 39. So now when it is factorizable, from your preparation you should know this. There will be a term in x and there will be a term in y, and the product of them will become this. Now the only difference from that earlier situations where you would have seen this is this coefficient of 6. Mostly we would be having an xy, and so we don't have to worry about what are the coefficients of x and y, but here we have to worry. So now the 6 could be split as 1 into 6. So I could have x plus 6y kind of a thing, but then the 6y into the constant is going to be the 15y. Okay, and now that's a little worrying because this will become a decimal, or else you could put that 6 over here, but then that 6x into a constant should make it 10x. Again, this constant is going to be a fraction. That means, so fractions are unavoidable, and the more let's say convincing reason is, if you read ahead, you will realize that we need to find the value of 2x and 3y. So the way of splitting the 6xy is not very difficult to be figured out as 2x and 3y. So one pointer I've already said, and now does that take care of that fraction problems? Yes, 2x into what is going to make it 10x into 5. And does 3y into what will make it 15y? 5. Oh, so everything fits into the picture. Now you just need to balance it out. Remember, we are taking care of this term, this term, this term. There's a 5 into 5, 25. So think you're adding a 25 to both sides. Okay, so the right hand side becomes 64. Now why I say this is an interesting question is, a lot of students hereafter are going to go into integer solutions to this situation. So they're going to put this down as a factor of 64, this another factor of 64. But if you pay careful attention, it says positive real numbers. It does not say integers or natural or whole numbers. So it is not about integer solution, students. In fact, this is about maximum minimum with positive real numbers. Real, they could even be fractions. Forget fractions, they can even be rational numbers with roots and so on. So the idea that you should have got from here is, this is a product. This is a product which is a constant, and I need to find the minimum value of some sum. So I'm going to compare the AM and GM of 2x plus 5 and 3y plus 5. Now remember, if x and y are positive numbers, 2x plus y is also positive, 3y plus 5 is also positive. So I can compare the AM, and when you take the AM, you are going to get this plus this, which I'm just writing it completely, a plus b by 2, okay, let me put it down, is greater than equal to the square root of the product. And this product is what we know. So it's not been such a difficult question that you could not figure this out, provided you could have focused that it's not integer solutions. So this is 64, square root of 64 is 8. 8 2s are 16. Take the 10 to the other side, and there you get your answer is greater than equal to 16 minus 10, 6. And remember, this is an inequality. It could also be equal to 6. So the minimum value of the expression is the one where we use the equality, and the equality is used when the equality, so the answer is done, students. The minimum value of this is 6. So now this is only further extra stuff. When is it equal? When the two variables are equal. That is when 2x plus 5 is equal to 3y plus 5. The 5 cancels, which just gives me that x by y is equal to 3 by 2. That still doesn't give me the value of x and y, but it tells me it's going to be when x and y are in the ratio 3:2. And you already have one equation in x and y. So it's going to go into tougher things, but then it's helpful if you still want to sit down and find the value of x and y. So you'll put x is equal to 3k and y is equal to 2k. Plug it back into this. So that's 3x into y is 6 into 6. That's a 6 into 6 is 36k square. 10x is a 30k. 15y is a 30k. So that's a 60k minus 39. So you get a quadratic in k. You can solve it. You'll get the value of k and plug that in. It's just that you can divide it by 3 here, right? 3 13s, 3 12, 3 20 and 13. So 12 into 13 is the product. The product is 12 into 13 and you should realize that 13 is a prime. You cannot break it further and the difference needs to be 20. Currently the difference is only 1. You need to make it 20. So if I give a 2 to that one, this will become 6. 6 into 26. And is the difference 20? Oh wow, the difference is 20. So I can factorize this and write this as 12 into k. The plus will be the 26 plus 26 by 12. 26 by 12, you could have reduced it or left it, and k would be minus 6 by 12 is half. So this will give me k is negative, but I'll not take the negative value. So k is equal to half is the acceptable value. If k is equal to half, x is 1.5, y is 1. So these are the values of x and y. You can plug them in, it will satisfy, and you can even plug them in here. You are going to get 6. Let's try. 2 into 1.5, that's a 3. 3 into y, that's a 3. Okay, so that's it, right? So we have got the minimum value as 6. In this question, a work can be completed by 58 workers in 141 days. And now it is assigned to some robot. On the first day, one robot, the rate is same as the man. So whether it's the robot or the man, the first day, it doesn't make a difference. Then on each day, one more robot joins. So by now you should be clear what the question is all about. So more and more men will keep joining. So you just equate the man days to get the work done. But then here, the nth robot that joins, that is twice as efficient as it. So instead, instead of working just with man days or worker days, I'll work with the rate also comes into picture, because everyone is going to be twice as efficient. So I'm going to work with assuming let the rate of what? One worker in one day be 1 unit. So why am I getting into this and not just doing man days? I have explained, because when I do man days, the robot who is going to get coming in later is more efficient, right? So he will be many more men than just one man. So instead of that, let me just make him do more units. So B1, so the work is very simply 58 into 141 units. Okay, so now the first day the robot comes in, there's he'll be doing only 1 unit because he is as efficient as the man. Now on the second day, the first robot will do his work, but the second robot is going to do 2 units because he is twice as efficient. Then on the third day, the first robot is going to be there and the second robot is also going to be there. And the third robot comes in who is twice as efficient as the second one. So this guy is going to do 4. and so on it is going to go on. So let's say if you want, there's no point in doing one more term. You should have seen the pattern. 4 will become an 8 next time. So let the work get done on the nth day. Now you need to look and observe. There are 3 terms, but the last term is 2 squared. So on the nth day, the work done will be 1 plus 2 plus 4 plus so on, right up to 2 raised to n minus 1. It starts with 2 raised to 0. So there are n robots working. And this sum should become, at least, if my work needs to be get done, it should be as good as 58 into 141. This many units is the work. So now I want to solve this. Now some patterns you should have picked up from your practice student. This is nothing big deal. So this is the next power of 2 minus 1. 2 raised to 1 this is. This is 2 square. So this will be 2 cube minus 1. And so on you would be having, this is going to be 2 raised to n minus 1. So to write it in a similar manner, I could write this also as 2 raised to 1 minus 1. And I need to add all of them. So when I add all of them, pay careful attention students, right? I'm doing 2 raised to 1, 2 square, 2 cube, 2 raised to n. Again I get that same pattern where powers of 2 are added. But this time it's not starting with a 1. So I'll just start it with a 1. Okay, on my own, well, I'll think there's a 1. So 1 plus 2 raised to 1, 2 square, 2 cube till 2 raised to n is going to be nothing but the next power of 2 minus 1. But remember that 1 is, I had introduced it. So instead of this minus 1, I'll have a minus 2. And then we have a minus 1, minus 1, minus 1, minus 1. How many times do I have a minus 1? N times. 1, second, third, so minus n. So this term has to be greater than, now I don't think so, we'll be able to solve this. So multiplying this is good enough. Right? Or if I look forward, I want to find the value of n. Solving such an equation algebraically is difficult. So I'm going to take values of n from the options and plug it. So I'll have to multiply this. 58 ones are 58. Try it orally, students. You should be able to do it. 58 into 4. 50 into 4 is 200 and 32, 237. 230. 58 ones are 58, 68, 78, 81. So I want this sum to be greater than this. So and find the value of n. So I'll start from my options and I'll choose the lowest option, which is 10. So if n is 10, 2 raised to 11, 2 raised to 10 is 1024. You should know 2 raised to 12 will become 2048. Minus 2 minus 10. Now this is not going to be as great as that. Now, in fact, you should even know that 11 will also not make it, because this will be the next power of 2, which will be 4096 minus something. But n is equal to 12 will make it 8192. Oh great, have I got, oh great. So I just need to check this 2 minus 12, is it? And yeah. So if I subtract a 14, subtract a 10, 82, 82 minus 4 is exactly equal to 8178, right? So it gets done exactly on the end of the 12th day. In this question, we have athletes running on a circular track. They are running in opposite directions. They start simultaneously from the same point. So typical standard situation. So I just pick up the opposite direction. Now the 11th meeting point is same as the 29th meeting point. So this is the key data here. And then the question starts. If the ratio of speed is k is to 1, k is a natural number, then how many values of k are possible? So the question is tough because it's how many values are possible and so on. So ignore the original start. Ignore this start. Take the 11th meeting itself. So I'm saying the 11th meeting let this be a fresh start. So all that I need to look at is, are they together? Yes, because why? Because they are meeting. They are together at same point, at same time. So it's a fresh start, and wherever that point is, right? So I don't know where that, so it might not be the same as the original start, but that original start is not relevant. I'm starting from this point itself. So this is the 11th start, 11th meeting, which I am saying is now consider this to be as the new start. And let me put that word also, new. Now, do I know that they start from this point here, and now the 29th meeting is actually, if I measure it from this point, is going to be 29 minus 11 is the 18th meeting from this point onwards. And the data given here is just that the 18th meeting also happens at this point. From now onwards, from here to the 18th meeting, it happens at that same point. So if you know the meaning, if you know the interpretation of ratios of the speed, so if the ratio of speed is k plus 1, so now we'll have to take a break. If k plus 1 is the ratio of the speed and they are in opposite direction, then we know that the k plus 1th meeting will happen at start. Will happen at the start point. So k could be 17, but so direct 17 plus 1, 18th meeting will happen at the start. So k is 17 is an obvious thing, but the question is asking how many values. So you need to understand that, oh, k plus 1, this is not the first meeting at start. They could have possibly met here earlier also, before the 18th meeting also they could have met. So what we are just saying is a multiple of k plus 1. Some multiple of k plus 1 is going to be the 18th meeting. This is a meeting at start. Okay, so they start from here, they meet again here, then they again meet and they again meet. Like for example, 9th time they could have met here. And if 9th time they could have met here, then 18th also they would be meeting here. They could have met here in the 6th time again, they could have met at the start point only. If 6 they have, then it's a fresh start. 6, after 6 another 6, 12, after 12 another 6, 18th also they'll meet here. Right? If you just say the meeting point is the same, it doesn't say that this is the first time that they are meeting at the same point. They could have met earlier also. So all that we need now is k plus 1 has to be a factor of 18. Because it's a multiple, n has to be some integral multiple or a natural number, and it is a factor, and we also know it has to be greater than 1. So if I want in details, k plus 1 can be 2, it should be more than 1, right? Can be 2, or it could be 3, 4 doesn't divide, 5 doesn't divide, 6, and now we see that 6 3s are 18, so 2 9s are 19, and 1 we had skipped, it could be 18. These 1, 2, 3, 4, 5. So how many values can it take? 5 is the answer. And if you want the values of k, it could be 1 or 2 or 5 or 8 or 17. The 17 was obvious when we saw 17 is to 1. Then they start from here, and the 18th time is when they meet here. But even if it was 8, 8 is to 1, that would have been the 9th meeting was there, which was the cases that I was explaining earlier. So 5 values.